let's try to do the systems of linear equation, or let's solve systems of linear equation using our first method, which is graphing. And this time, I'll be using IXL. This is for us to have precisions on the graph. Okay, so let's start. So in this one here, so it says solve the systems of equation by graphing. Okay, so first, what we have to do is what we have to graph our two equations here. This is our equation 1 and then equation 2. Okay, let's start first by graphing our equation 1. Okay, on our equation 1, it says y equals negative 2x plus 2. Okay, sorry, negative 2x, negative 2 third x plus 2. And then the second equation, y equals 1 half x minus 5. So first, let's try to identify our slope and then our y-intercept. So on the first equation, our slope is negative 2 over 3. And then on the next, our b is 2. Okay, let's focus first on the first equation. So on the first equation, our y-intercept is 2. Okay, where is 2 on the y-axis? It's here, right there. Now, again, now we're on the first equation. Now, what do we do next? What's our slope? Negative 2 over 3, right? This one is our slope, negative 2 thirds. But remember again, the formula, rise over run. So it means to say that our rise is negative 2, our run is 3. So starting from this one, you have to rise negative 2. And since it's negative, we go down. From this point, 1, 2. How many run? 3. 1, 2, 3. This is our first equation. This is the graph for the first equation. Now, we will just do exactly the same thing on the next equation. Equation number 2. Y equals 1 half x minus 5. So our m here is what? Our m is 1 half. And then our b, what's the value of our b? Negative 5. Okay. So let's start first by looking for the y-intercept, negative 5. Where is negative 5 on the y-axis? It's actually, okay, let's take this one. Okay. Where is negative 5? Negative 5 is, it's here. Now what do we do? Let's try to go now on our slope. What's our slope? 1 half. Again, this is rise, this is run. So starting from this point, we go how many? How many rise? Only one. 1. How many run? 2. 1, 2. There. And then the next thing you have to do is we just have to take a look at the what? Intersection of the two lines. So what's our intersection here? So this one, right? This one is our intersection. Now, what is the coordinate at this point? Let's check. What's the value of x on this one? The value of x is 6, and the value of y here is negative 2. So the answer is 6, comma, negative 2. So let's put that here in our answer. So the answer here should be what? 6, comma, oops, what happened? Negative 2. Okay? What's happening? Negative 2. Huh? What's wrong with this thing? Okay. So it's 6, comma, negative 2. Okay. There. Let's have our next example. Okay. So on this one, again, we will just do exactly the same thing. What do we do? We will just grab our two equations here. Okay. What is our first equation? Okay, this one. This is the second equation. Okay, let's identify first our m and b. The m here on the first equation is negative x, right? So what's our m? So negative 1. And then what's the value of our b? Negative 3. Okay, let's plot first. So the first equation, y equals negative x minus 3. Okay, our b is negative 3. Where is negative 3? It is here. And then let's go on our slope. The slope is negative 1. So just to make it a fraction, what's our denominator? I'll just put here 1. Okay, so rise, run. So our rise is negative 1. So starting from this point, rise of negative 1, run of 1, there. That's it for the first equation. Now let's go to the next equation. Okay, the next equation is 1/3 x plus 5. Okay, our m here is of course 1/3. And then our b is 3. Sorry, it's 5. So where is 5 on the y-axis? Again, now we always start with the y-intercept. Where is 5? It's here. Okay, now where is... Okay, okay, what's our slope? 1/3. Again, rise over run. So what's wrong with this thing? Anyway, rise over run. So how many rise? 1. How many run? 3. 1, 2, 3. There. And then just check again on their intersection. What's the intersection? This one, right? What's the coordinate here? The value of x here is negative 6 and the value of y is 3. So negative 6, comma 3. That is our answer. So on this one here, let's put here negative 6 and then comma 3. Okay. What's wrong? Okay. Maybe let's do this one as our uh, last example. Okay. So we have here y equals 3x plus 1 and then okay y equals x minus 3. So what will happen here? So again, what's our m here? Okay, I cannot write. So m equals 3 and then our b is of course 1. Let's graph. Where is 1? It's here. Now what's our slope? 3. Just make it a fraction. So 3 over 1. 3 rise, 1 run. So from this point, how many rise? 3. 1, 2, 3. How many run? 1. There. And then that's it. Now let's go on the next equation. Our m here is 1 and then our b is negative 3. So let's plot first our y-intercept negative 3. Where is negative 3 here? It's this up. Sorry. What happened here? There. I should first click this one. Okay. Let's go back again. Our slope on, sorry, our intercept on the next one is negative 3. Where's negative 3? It's here. And then, what's our slope? 1. So 1, just make it a fraction. 1 over 1. 1 rise, 1 run. So from this point, how many rise? 1. How many run? 1. There. And then what's the intersection? This point, right? So what's the coordinate here? Negative 2, comma, negative 5. Okay, so the answer here should be negative 2 and then comma negative 5. There you go. Okay, I guess let's try one more here. Let's jump a level here. Okay, there. Now this one is already a different scenario. Now what if, okay, we have x plus y equals negative 6 wherein the variable is not anymore separated. Okay, so how do we answer this kind of question? This is a good question actually. So x plus y equals negative 6, right? As you can see here, it is not in the our what do you call this one? the slope-intercept form. Remember, y equals mx plus b? Because this one here is actually in standard form. And then, sir, how do I make it in a slope-intercept form? Simple. In slope-intercept form, y is separated. It's alone on the left side. So what do we do? The x plus y equals negative 6. To make the y alone, what we do is I'll just transpose the x to the right side. What will happen here? Y is equals to, what will happen to x? It will become negative x, and then just copy the minus 6. So this one here, I can rewrite this as y equals negative x minus 6. And then this one will just remain as is. And then after that one, let's do the typical way of graphing. So what's the value of our? Because if it's in slope intercept form, it's easier to look for m and b. That's the purpose of it. So what's the value of our m here? M is negative 1 and the value of b is negative 6. So let's graph it. Where is negative 6 on the y-axis? It is here. Now, what's our slope? Negative 1. Let's just make it a fraction by putting 1 here. So again, rise, run. So from this point, how many rise? Negative 1. So we go down 1. How many run? 1. That's for the first equation. Okay? Now let's go on the next equation. Y equals x. What's the value of our m? And then what's the value of b? As you can see here, y equals x. There is no given value of b, right? I mean, there is no y-intercept. So what will happen here? The b here or the y-intercept is 0 because there's nothing. Okay? And then m, what's the value of m? What's the number before the x? Of course, it's 1. And actually, as you can see, this one is a proportional relationship. And when you say proportional relationship, its graph should always touch the 0, comma 0. And actually, you can see it here because our y-intercept is 0. So we're 0 on y. Okay, let's change first. Okay, we're 0. It's here. And then, what's our slope? 1. Just make it a fraction. And then rise, overrun. Okay. 1 rise, 1 run. So from this point, how many rise? 1. How many run? 1. Now, what's the intersection? This point. What's the coordinate here? The value of x here is negative 3. And the value of y is negative 3. So negative 3, comma, negative 3. That is the answer. So I'll put here negative 3 and then negative 3. Okay?